Okay, so let's just dive right in. We're living in what should be a golden age of engineering, right? We've got tools that can spin up entire data centers in seconds, deploy software across the globe in minutes. I mean, from the outside, it looks like we've totally solved complexity. But if you're an engineer, you know, on the inside, something just feels wrong.
And this quote right here, it just nails it. This is the core tension we're going to unpack. We got so good at building these incredible, complex, distributed systems, but we completely forgot to account for the most important and most limited component in that whole system, the human brain.
And that brings us to what you could call the DevOps paradox. We have more powerful tools than ever before. Our velocity, in theory, is way up, but so are system incidents. And maybe the most important one, so is engineer burnout. So what is going on? How is all this amazing progress leading to so much friction and exhaustion?
Well, to really understand this paradox, we have to look away from the computer screen for a minute and look at the hardware that we all run on, our brains. Turns out there's some really crucial neuroscience that the entire tech industry has, for the most part, just completely ignored. The key is something called cognitive load theory. Now, this isn't new. It was formalized back in the 80s by a guy named John Sweller. And its main idea is brutally simple. Our working memory, you know, that mental scratch pad you use for active thinking and problem solving, it's tiny. Meanwhile, our long-term memory is gigantic. But that bottleneck, the part that processes anything new, is incredibly small.
4. That's it. That's the magic number. The research is pretty clear. Our working memory can only really juggle about 4 new pieces of information at any one time. Not 50, not even 10, just 4. And when we try to push past that limit, our ability to think clearly just falls off a cliff. Our error rates shoot up and stress starts to take over.
Now, this cognitive load comes in 3 basic flavors. First, there's intrinsic load. That's just how hard the problem is, and we can't really change that. Then there's germane load, and that's the good stuff. That's the effort that actually helps us learn and build new mental models. But the one we really need to focus on is extraneous load. This is the useless friction, the mental junk drawer. It's all the overhead caused by confusing tools, bad UI, and just unnecessary complexity. And this is the part we can actually fix.
So the big question is, how does a typical modern DevOps environment stack up against this 4-item limit? Well, spoiler alert, not well. It's almost like we've accidentally engineered an entire architecture of overload.
Just think about a single deployment failure. To figure out what went wrong, an engineer can't just think about their code. No, they have to mentally load up and simulate this entire chain of incredibly complex systems, all at the same time. You've got your code logic, the CI/CD pipeline, the Kubernetes cluster, network policies, cloud permissions, observability data. That's not one thing to think about. That's 6 or more things right there. We've completely blown past our 4-item limit before we've even started. And this really gets to the core of it. The problem isn't that distributed systems are complex. Of course they are. The problem is that we are forcing a single human mind to hold all of that complexity at once. We've successfully distributed our systems, but we completely failed to distribute the cognitive load that's needed to understand them.
And believe it or not, it gets worse. You know, in operating systems, there's a term called thrashing. It's when a computer spends all its time swapping things in and out of memory instead of actually doing work. Well, engineers today are living in a state of cognitive thrashing. Every Slack notification, every PR review, every meeting, it's a context switch. And the research on this is staggering. It can take up to 25 minutes to get back into a state of deep focus after just one tiny interruption.
This constant overload, this state of cognitive thrashing, it's not just inefficient. It leads directly to a really serious and frankly often misunderstood consequence for our entire industry.
We have to start thinking about burnout differently. It is not a personal failing. It's not an HR problem to be solved with a yoga class. It is a predictable neurological outcome of sustained cognitive overload. It is a bug in the very system we've designed, a system that's just full of ambiguity, constant interruptions, and fragmented tools.
And the biological impact is very real. When you're constantly overloaded, your body is flooded with stress hormones like cortisol. And you know what that does? It actually reduces the capacity of your working memory. It damages your executive function, the very part of your brain you need for complex planning and problem solving. It's a cruel irony. This system we've built is actively making us worse at our jobs.
So what do we do? How do we fix this mess? Well, if an engineer's working memory is the single most constrained resource we have, then we have to start designing our systems to protect it. And this is where we need to completely rethink the real purpose of platform engineering.
And here's what that looks like in practice. On the left, without a platform, an engineer has to juggle all this stuff. Kubernetes YAML, IAM policies, CI scripts, secrets, a dozen different tools and concepts. But a well-designed internal platform, it acts as a cognitive abstraction layer. It collapses all of that extraneous, useless load into a single, simple, understandable command.
And this, right here, might be the most important takeaway. The whole point of a platform isn't just developer convenience. It's not just about making their lives a little easier. Its number one job is to act as a cognitive shield. It offloads all that complexity from the fragile human mind onto the resilient machine. It is cognitive protection.
So, by protecting our working memory, we do a lot more than just prevent burnout. We actually create the conditions necessary for that state of peak performance that psychologists call flow.
To get into a flow state, you need three basic things: clear goals, immediate feedback, and minimal distraction. Think about our current DevOps environments. They actively violate all three of these all the time. We need to start engineering our systems to provide these things by default, making flow an intentional property of our infrastructure, not some lucky accident.
And this all points to a fundamental shift in how we have to think about engineering performance. For decades, we obsessed over optimizing compute, memory, and storage. But those things are basically infinite now. They are not the primary bottleneck anymore. The real bottleneck today is human attention.
So I'll just leave you with this question to think about. In an age where compute and data are essentially limitless, what is the one truly scarce resource that we have left?
The answer isn't CPU cycles, it's uninterrupted human thought. And designing systems that fiercely protect this resource isn't some luxury. It is the absolute key to unlocking real innovation and genuine engineering velocity.
So, the future of high-performing engineering teams isn't about frantic motion and making pipelines run a few seconds faster. It's about achieving true velocity, which looks like deliberate, focused, sustained progress. And that is only possible when we stop designing systems just for machines and start designing them for the human mind. The real goal is cognitive alignment. When we get that right, everything else will fall into place.